Welcome Chemistry 3.4. So by now you should have taken this quiz and we're ready to grade it up. So 3.4 has 4 new points at the top, which are physical properties, chemical properties, physical changes, and chemical changes. I guess if you missed it by a word out of 2, I could go half, but that isn't really the spirit of what those words are. But 1 to 4 again, physical properties, chemical properties, physical changes, chemical changes. Then we fish into some older words. So in the interest of saving time in video making, why don't you write down the timestamp right now on this YouTube video, because tomorrow, instead of rereading all these answers when we would grade the tomorrow quiz, I'm just going to tell you to go back to this time, because it'll be all the same answers in all the same order here from number 5 down. So that'll save me a little bit of video making bother. But 5 is going to be physical states. If you missed that by a word, do half. Homogeneous is same throughout. Heterogeneous is not the same throughout. Another name for heterogeneous is a mixture. The name defined example category is a homogeneous mixture. You need both of those words. If you just said mixture, you're wrong, because a mixture is the opposite of a homogeneous mixture. There's solutions, and there's pure substances. Homogeneous mixture is 2 or more pure substances. If you don't say pure substance, you're out at least a half. Whose proportion can be varied without limit. If you don't have the thing about proportion can be varied without limit, you're off at least a half. If you just said 2, tomorrow we'll take points off at 2 or more. If you just said 2, I'll let that go one last time, but starting on the 3-5 quiz, we want to say 2 or more. The only example of that is air. And if you have grading questions, just put a question mark by it now while it's fresh on your mind, and we'll sort those out in person. Solution you could do as an example, like Kool-Aid or Gatorade, or pretty much anything dissolved in water. Brass would even work. That's not dissolved in water, but it is a solution of metals. Solution, we're going 2 or more pure substances again, but the proportions are varied within limits. You can't unlimited put sugar in your Kool-Aid. It at some point stops working out for you. Pure substance means there's no variation of proportion. For an example there, you could do any element or anything that has a formula like H2O, CO2, that kind of stuff, acids, salts, sugars, those kinds of things. A compound is a pure substance that can be broken down into 2 or more simpler ones. I think previously I said if you skip the or more on that question, we'd go half off today. You do need to say it's a pure substance. That will be a half off kind of issue. But the key idea is it can be broken down into 2 or more simpler ones. Elements, you can just say can't. It's the same concept, but just the opposite. So if you just said can't, you're good. If you want to write the full thing, it is a pure substance. It can't be broken down into anything simpler. An atom is the smallest piece of an element that can exist and still show the properties of that element. Molecule is the smallest particle that can exist and undergo chemical change. That wasn't the greatest definition until you learned what a chemical change was on quiz number 4, and we'll double back and fine-tune that in a minute. The bigger thing would be molecules, because molecules are made of atoms. Molecular formula is the preferred answer for the way of expressing the composition, but there was another synonym answer for that. Law of definite proportions is what I prefer for 24, but there was a synonym answer for that as well. You could look those up if you're using those just to confirm you used the right thing. And then the last question about what happens to elements when they form compounds is they lose their own character. So next time up, there's a homework you can do that'll be 1, NOPQ, 2, A and B, and 9, 10, and 11. What the 9, 10, 11 does is going to ask you whether you have a physical or chemical property or change. So I'll have to explain that now, and then that'll help us out. So the basic difference, the properties are facts. Whether it's a chemical property or physical property, it's just a fact. Like, this is green, this can melt, this is shiny, this can be burned. The properties are just facts about things. The changes need to be an action or a process. They're going to need to involve a verb that probably ends in ing, like I am burning this, I am cooking this, I am evaporating this, I'm freezing this, I'm whatever. If you're in action doing it, that's the change. If you could do it, that's a property. Okay, so like I could freeze this water and make ice. That's a fact. That's a property. I am freezing this ice in the freezer right now. That's a change. That's a process. Okay. So that's how you tell a property from a change. The property is just a fact-based sentence. The change is an action. It's an activity that's ongoing right now, probably with an ing ending type verb. Then physical means you can do this without changing the thing that you have. It's not going to make anything new. Water will still be water. H2O is still H2O when you do certain things to it. To be a chemical item, that can only happen when a new thing is formed. Okay, so physical, some examples of physical would be the color of something, the odor that it has, the way it tastes, its density, its melting point, its boiling point. Those are physical properties. So a physical change would be based on that, like I am melting this, I am boiling this, I am cutting it, I'm crushing it, I'm dissolving it, I'm whatever. If you dissolve sugar in water, that didn't make a new thing. The sugar is still sugar, the water is still water. If you want to get the sugar back, you just evaporate all the water and you're left with a bunch of sugar again. Okay, that's not any kind of a permanent new thing that got formed if you dissolve sugar in water. For a chemical item, something new is formed. So chemical properties would be like this could rust, or this can burn, or something along those lines. If you state the sentence as a fact, that's a chemical property. If you state it as an action, I am burning this, this metal is rusting, I'm baking this cake, I'm digesting my meal, I'm whatever, with an action, that's a chemical change. Okay? Usually the evidence you have a chemical change is that either a gas is produced, meaning you can smell it, or there's a change of color. Like if you burn things, you burn wood, it's black. Okay, that's a color change. You burn wood, there's smoke, you can smell it. That's those are chemical changes. You bake a cake, you bake cookies, you cook anything in the oven. You come home, you can smell it, right? Any of that stuff, it's made a new thing. You put a cake in the oven, it's definitely not the same thing coming out as it is going in. Okay, you'd have to drink it through a straw on the way in, you're cutting it with a knife on the way out. That's a whole new kind of item coming out after you bake or cook or whatever, something. So that's the difference. I have somewhere in my pile of papers here, I have the same kind of game. If you want to play along, whether this is chemical or physical, go ahead and feel free. So here are some items, and you could try to decide chemical or physical. So here's my list. Burning of coal, tearing of paper, excavating of the earth, exploding TNT, kicking a football, contracting a muscle, forming clouds in the air, making rock candy by evaporating water, digesting one of our school lunches, bending a gold coin to show off. Those are all changes. None of those were properties, because those were all ing facts, or ing actions. None of those were stated as a fact. Okay? The ones that are chemical would be the ones that something new is formed, something that the color changed, something that a smell is produced. So the chemical changes there would be burning coal. You would smell that. That would make smoke. Exploding TNT. That would definitely make a new thing. Fire, smoke, different things. Forming clouds in the air would be a chemical change, because there weren't clouds and then there were. So you made a new thing happen there. I don't think the evaporating water here is the correct answer handed down to me by prior generations. So that was on this paper given to me by somebody else who said that's chemical, and I disagree. I think evaporating water to leave sugar behind, I think that's physical. You didn't actually form a new thing. There was sugar there. You evaporated the water. The sugar was still there. So I disagree there. Digesting is definitely chemical. A new thing is formed when you digest your food. And I won't go into graphic detail on that if you don't understand how your food is different after you digest it. The physical stuff would be like tearing the paper. Like this is paper, I tear it, it's still paper. It doesn't make it a different kind of paper when I tear it in half, it's still the same paper. Excavating earth just means you're digging. So if you dig up a bunch of dirt, it's still the same dirt. You didn't change anything or make anything new. It didn't change color, it didn't smell. It's just digging. Kicking a football, that's a physical change. Physical change. Contracting your muscle, that's a physical change. You still have the same muscle. You flex and then you unflex. It didn't change what your muscle was made out of. Bending things, that's also physical. You didn't make a new thing, it just got bent. If you want to keep playing, I'll keep going along here. I have another paper that does the same thing. This came from some book somewhere. So the 6 choices here, this can conduct heat. This is 6 inches long. This can burn. It's combustible is a word for that. This is brittle. This is acid resistant. This displaces hydrogen from water. Those are all properties because those were all stated as facts. So the physical properties are ones you could measure without forming a new thing. Physical would be this can conduct heat. If you heat something up and then cool it back down, it's not like you have a new pot because you heated it up and cooled it down. It's still the same pot. It's still made of the same stuff. This is 6 inches long. That's a physical property. It didn't change what it's made of when you measured it was 6 inches long. To be brittle, that's physical. You break something to see if it's brittle. It's still brittle. It's just in 2 pieces. That's a physical change. You didn't make a new thing. Chemical, displacing hydrogen from water would be chemical. If you have H2O and you take away the H, you don't have water anymore without the H part of H2O. A new thing would be formed. There would be oxygen. That's a chemical change. To burn something, that's a chemical change. Anything you burn is going to make a new thing. It changes color, it makes a gas. If you get acid involved also, that's a chemical change. You start throwing acid into things, acid is going to change the composition of things. So those are chemical. One more go round. I have one more paper that plays that game if you want to keep playing. If you're done playing, well, you can just fast forward through this, I guess, till I put the papers down. This paper has silver tarnishing, wood burning, water freezing, milk souring, and steel magnetizing. So these are all changes because they're ing sentences. They're not properties stated as facts. The chemical is where you get a new thing. Milk souring, you get a new thing. If you let your milk get old enough, it even gets clumpy and really gross. As milk ages, it ceases to be milk and starts to become gross stuff. Burning wood turns into ash, that's a new thing, that's chemical. Silver tarnishing and rusting is sort of a similar kind of thing. It makes a new thing there. So that would be chemical. The other 2 were physical. Freezing water, water is still water. Whether it's ice, H2O, or water, H2O, it is still H2O. There's nothing permanently new formed when you freeze water. Magnetizing steel is also physical. You have steel, it's steel. You magnetize it, it's still steel. It just can stick to your refrigerator, but it's not made of anything new. It's still just steel. So that's the kind of stuff you're trying to do on 7, 8, 9 in terms of quiz prep. We are reading 3536. 3536 is going to have 9 new points, all fill-ins. As I said earlier, everything from 5 down is just going to stay the same. There's going to be no differences on any of that. So when we grade tomorrow's quiz, I'll just send you back to the timestamp on this one to watch the beginning again. Then the top 4 is going to change. It's going to ask 9 points worth of questions instead of 4. So it's going to say, instead of 1 and 2, it'll say explain and give an example of a physical property and a chemical property. So you'd say a physical property is observed without changing its composition. You'd say chemical property is observed only when a new substance is formed. Examples you could do for a physical property would be, again, color, odor, taste, melting point, boiling point, others. Chemical properties, you could do things like iron is able to rust, wood is able to burn, things like that. Then it will do another 4-point question, explain, give an example, physical change versus chemical change. Physical change, you would say changes other than change in composition. For example, melting, boiling, cutting, ripping. For chemical change, you'd say a new substance is formed. Rusting, burning, baking, cooking, things like that. And then it'll also ask what's the difference between a property versus a change. And you'd say that a property is a fact, a change is a process or an action or an activity. You pick a word, any word that you like there on that. And that's where we're headed for next time. See you guys. If you run into homework questions, give me an email. We'll set up a Zoom.